status at work, and the cycle continues. So next I will talk about our interruption UI, which is the connection between our software agent and the user themselves, how our software agent will interact with the user. First, our first method interruption is a pop-up screen. This is also the interruption interface for our pneumatic IM. So whenever our user reacts to an interruption method, this is the screen that they will get. This screen pops up to the forefront in this particular method. We notify the user why we have interrupted them, and we take a brief survey on the bottom of how intrusive was this particular method to the user. Next, we have the sys-tray balloon, which in the Windows environment appears on the lower right-hand corner sys-tray. A dialog balloon pops up with our message, please update your status, for 30 seconds before it fades away. Clicking on this balloon or our pneumatic icon will bring up the pop-up window that we have just seen. Next, we have a fading window, which is a little hard to see on this projection, but we have a semi-transparent window up here on the top left-hand corner of the screen with the message, please update your status. And clicking on this window will bring up the pop-up notification window. It is hard-coded at 75% opacity for rule base and determine how much the historic and the current sensor distribution has diverged, a 50 to 100% opacity for our KLD-based algorithm. And next we have audio chime, which I will try to play right now. Which will play when the interruption is invoked and the user will need to open up the pneumatic to update their status. Finally, we'll have a cursor change, which will change the user's mouse cursor to this particular icon, a much smaller version of this, and it won't change back until they update their status in pneumatic IM. In our study, we recruited 15 users, and we studied them over a 6-week period. The participants were recruited from our mailing list and flyers around UCI. And the participants were given $1 a day for up to $42 for 6 weeks of their compensation. The way we conduct our study was the users will install pneumatic IM on their computer, hook it up to their Skype, Facebook, and Twitter. And after every context change, we will choose at random a pair of our 6 context detection algorithm and of the 5 interruption UI. So, with this study, what do we find? First, we found the accuracy of our context detection. You can see that startup time was accurate 100% of the time. That meant that when we interrupt the user for their status change, 100% of the time the user changed their status when they started up the pneumatic IM, which was expected. Next, we see that KLD, our sensor-based algorithm, was accurate almost half the time. And it's important to note that KLD encompasses all the rules that's above it, that it takes as part of the sensor reading, plus the virtual sensor. And if you'll notice that in the previous our rule-based failure slide, the Wi-Fi MAC address change was only accurate 11% of the time, but it's dramatically improved with KLD as we incorporate other sensors. So next we have the intrusiveness of each of our UI methods. Our sys-tray balloon was the least intrusive. Users rated as not intrusive 89% of the time, while while fading window and cursor change was noted as the most intrusive. In our study, we wanted to find out why users took a long time to react to our interruption methods. So if the user took more than 3 minutes to respond to pneumatic IM, we present them with a second survey asking for a reason why it took so long to notice us. The reason being from I was away from the computer, I didn't notice interruption. Interruption ignored because my status was the same. Interruption ignored because I was busy. I'd forgotten about the interruption. And other fields which, when they selected, the user can input a custom message, custom reason, so that we would have a better understanding of the user's behavior. And from this survey, we got these data. It was very interesting that almost across the board, half we had another option for the user to specify that they were away from the computer. We believe that this meant that nomadically, users were not actively engaged with the computer about half the time. Another interesting note that we thought was interesting was that there's a couple of scenarios that we did not account for, which the user was playing a full-screen game and it covered up all of our interruption methods and it muted our audio. And also another scenario was that the user would have their sound off. Maybe they were in a meeting when they were in class, and which rendered our audio interruption kind of powerless. So what does all this mean? So from our data, we observed that our two novel interruption UI, our fading window and our cursor change, were the two most intrusive UI techniques. And we observed that cursor change was the most effective, meaning people respond to it the quickest before our 3-minute timeout, but it was the most intrusive. However, this was interesting, is that the sys balloon UI was nearly as effective, but it was the least intrusive, meaning that people react to the sys balloon almost as quickly as they did with the cursor change, but people did not find that as intrusive as the cursor change. And also, we observed that KLD metric as a virtual sensor could be more effective with hard-coded rules with traditional sensors, more effective than hard-coded rules with traditional sensors, as we showed in the graph before, where KLD was accurate almost half the time. So what do we think about this? Non-persistent interruption could be just as effective as persistent one, while being less irritating. Our less persistent interruption would have been the sys balloon or audio chime, while the persistent one would have been the fading window, which remained on top, and our cursor change, which remained there until they update their status. So this alert, which means this non-persistent alert could help allow users to easily assess the cost of the intrusion on their own and respond accordingly. However, there also might be that the user would just physically away from their computer during the non-persistent interruption, and it never made any effect on them because they weren't there noticing. And also, in terms of context change, we felt that optimized context change should be a hybrid of both virtual and traditional sensor, as we have proposed with our KLD algorithm. So, thank you for listening to my talk. I'd like to thank my advisor, Harrison, for helping me with the study, our grant provider, NSF, and UMAP for giving me the honor to talk with you guys today, and all the users who have helped provided the data that made this study possible. Mahalo, thank you very much, and do we have any questions?
So a question twofold to do with platform and to do with accuracy. So I'm assuming it was both for a desktop platform.
Yeah.
For a mobile platform.
No, it was for laptops. We recruited users specifically, people who took their who used their laptop in more than 2 locations a day.
So in the scenario you talk about going to Starbucks and things like that. And so I'm just wondering, would you consider firstly using a smartphone, a mobile platform rather than a laptop? And secondly, with regards to the accuracy, how was that defined? So for example, if someone went to Starbucks and didn't open up the laptop, so because laptops when you open up, smartphones are always on, the service running in the background, how did you measure accuracy?
Well, in terms of the platform, we wanted to do a smartphone, but we just didn't have time to develop the app for it. So that was very good point that we just didn't have the resources to develop the app on the smartphone. And we felt that if the user didn't open the laptop at a coffee shop, then there's really no way for people to interrupt them on their mobile device, which is what we were studying about, because they're not actively engaged in the computer, which kind of give their virtual interruption in a mood because it's not affecting them physically. That makes sense.
So something were possibly just not measured.
Yeah. Yes. No. We measured interruption in terms of being interrupted while working on your mobile laptop device.
Do you have both? Are you going to read this for mobile laptop?
You want to use? We want to.